Assalamualaikum. My name is Hasha Kisina binti Muhammad Elaris Muhammad Zalizan. My metric number is 1250300. Today, I will be presenting our topic relation, function and graph. So this topic, relation, functions and graph, is the concept provide a systematic way to analyze relationship, represent mappings and model interconnected system. According to Rosen 1999, these concepts are fundamental in understanding mathematical structures used in computing. In addition, Baldwin, Walker and Henderson 2013 state that relations, functions and graph form the foundation of many computer science applications, including database, algorithm, computer networks and artificial intelligence. In this presentation, I will explain the concept of relations, function and graph, discuss their properties and show how they are applied in computer science. So let's begin with the concept of relation. A relation is defined as a subset of the Cartesian product of two sets where each ordered pair represents a relationship between elements. In computer science, relations are commonly used to model connection between entities such as users, database and computer networks. They are also the foundation of relational database system for organizing and managing data efficiently. For this example, we have a set of students and a set of courses. The relationship consists of the ordered pairs shown on the slide. The ordered pair indicate which student is enrolled in which course. For example, Ali is enrolled in both discrete mathematics and data structures. Sarah is enrolled in database systems while John is enrolled in discrete mathematics. This example represents a many-to-many relationship where one student can enroll in multiple courses and one course can have multiple students. Now, let's move on to function. A function is a special type of relation where every element in the domain corresponds to exactly one element in codomain. In this example, the domain is the set 1, 2, 3 while the codomain is A, B, C. The function is represented by the ordered pairs 1A, 2C and 3A. Notice that each input is connected to only one output. Although the two different inputs may have the same output, a single input cannot be connected to two different outputs. Since every input has exactly one output, this relation satisfies the definition of a function. Now let's compare relation and functions. Both are subsets of the Cartesian products and both are represented using ordered pairs. However, in a relation, one input may be associated with more than one output. In contrast, a function requires every input to have exactly one output. Therefore, every function is considered a relation, but not every relation can be classified as a function. This is the key difference between the two concepts, which is relation and function. Now let's look at graphs. A graph is a mathematical structure used to represent relationship between elements using vertices and edges. Graph help us visualize relation, making it easier to understand the connection between different elements. In this example, the relation is represented using a directed graph, also known as a digraph. Each vertex represents an element while each arrow represents the relationship between two elements. Graphs are widely used in computer science, especially in computer networks, routing systems, and data structures. Now let's discuss the three important properties of relation. The first property is reflexive. A relation is reflexive if every element is related to itself. In this example, the ordered pairs 1, 1, 2, 2 and 3, 3 are all present, so the relation is reflexive. The second property is symmetric. A relation is symmetric if whenever A, B exists, then B, A must also exist. Since all the ordered pairs are of the form A, A, reversing them gives the same ordered pair. Therefore, this relation is symmetric. The third property is transitive. A relation is transitive if whenever A, B and BC exist, then AC must also exist. In this example, this condition is satisfied, hence the relation is also transitive. Now let's solve the given example. We are given the set A 1, 2, 3 and the relation is defined as x the power of 2 must be greater than y. First, we substitute each value of x. When x equal to 1, we get 1 the power of 2 is equal to 1. Since 1 is not greater than 1, 2 or 3, no ordered pairs are obtained. Next, when x is 2, we get 2 the power of 2 is 4. Since 4 is greater than 1, 2 and 3, the ordered pairs are 2, 1, 2, 2 and 2, 3. Finally, when x is equal to 3, we get 3 the power of 2 is equal to 9. Since 9 is greater than all elements in the set, we obtain 3, 1, 3, 2 and 3, 3. Therefore, the final relation is the set of ordered pairs shown on this slide. Next, we determine the properties of this relation. First, the relation is not reflexive because the ordered pair 1, 1 is missing. Second, the relation is not symmetric because 2, 1 exists but the reverse pair 1, 2 does not. Lastly, the relation is transitive. For example, since 3, 2 and 2, 1 exist, the ordered pair 3, 1 also exists. Therefore, these relations satisfy the transitive property. Overall, this relation is not reflexive, not symmetric, but transitive. Now let's look at some real-world application in computer science. The first application in database system, relations are used to organize and connect data through tables, primary keys, and foreign keys, allowing information to be stored and retrieved efficiently. The second application is computer networks. Relation helps model the connectivity between computers and networking devices, making it easier to represent communication links and routing paths. The third application is logic and computing system. Relations describe relationship between different states, conditions, and computations. This is important in software verification to ensure the computer system functions correctly and reliably. These examples show that relations that are not only theoretical concepts but also practical tools used in modern computing. In conclusion, relations, function, and graph are fundamental concepts in discrete mathematics and play an important role in computer science. They provide systematic way to represent relationships, describe mappings, and model interconnected systems. These concepts are widely applied in database, programming, computer network, and artificial intelligence to solve computational problems efficiently. Therefore, understanding this concept is essential for developing efficient, reliable, and well-structured computing systems.